Hey, everybody. Welcome to Statistical Methods. So these first set of videos are going to be focusing in on Guided Notes 1.1, where we're going to be overviewing statistics and looking at data classification. So starting off with some definitions, what does statistics even mean, right? What's a population? Who's the sample? So statistics is any time we are gathering, describing, and analyzing data, right? We run statistics when we want to answer questions about life. Now, it can be confusing because we have statistics, the overall study, right? The science, but then we also use the word statistics to describe numerical descriptions of sample data. So like if I say the average GPA is 3, the average miles per gallon is 20. We refer to those values, that GPA or that average mileage, we refer to those as statistics. Those are very specific descriptions, right? Those actual numbers are called stats, as well as we use the word statistics for the overall science, right? Everything, this entire class is looking at the science of statistics. So as we focus in on these statistics, whichever version you're looking at, we are always focusing in on a population. So a population is whatever group you're wanting to study. The group of students, the group of vehicles. However, a lot of times a population is difficult to focus in on. Right? There's a reason why they only take the United States Census every 10 years. It's really hard to stop and go and talk to every single person that's a part of the United States. So the population is the big group who we really want to focus in on, but the sample is a part of that population, the ones we actually go and talk to. So if I was looking at the population of statistics students, I'm talking about every single person in a stats class. However, I don't want to go talk to every single one of them. I'm only going to talk to a smaller group, a subset. I'm just going to talk to y'all. You would be part of the sample, the smaller group I actually talk to, and you represent the big group of overall everyone that's in stats. So big groups versus a smaller group I can actually talk to. So let's focus in on these definitions with some examples. Example 1, identify the population and sample for the following. In a survey of 834 employees in the United States, in a survey, 834 employees in the United States were asked whether they thought their jobs were highly stressful. Of the 834 respondents, 517 said yes. Let me pause this example real quick. If you have not yet printed your guided notes, please do so. These videos are designed to walk you through the guided notes, that note outlines, and take the place of our face-to-face learning. So as you watch these videos, you should be filling out the notes for yourself. So who's our population? Who is the big focus group? Don't look at the numbers, look at the people. We are wanting to look at employees in the United States. Employees in the US. You can imagine that is a huge group of people. Huge. I cannot go talk to every single one of them. It's not feasible. The sample is, who are the ones I actually talked to? Those would be the 834 employees who actually took the survey. So hopefully we understand that the population and the sample should be related to each other. Population, the big group, the sample, the smaller group I actually got to talk to. Example 2. Again, we're still just identifying the population and sample. In the journal article, Residential Carbon Monoxide Detector Failure Rates in the United States, well, that's a mouthful. In that journal article, it was stated that there are 38 million carbon monoxide detectors installed in the U.S. When 30 of them were randomly selected and tested, it was found that 12 of them failed to provide an alarm in hazardous carbon monoxide conditions. Who are the population and sample? So, hopefully we can all identify that we are talking about carbon monoxide detectors. All right, that's the entire focus of our conversation, carbon monoxide detectors. The population is the big group of them, right? Basically, every carbon monoxide detector, whoops, helps if I spell correctly, installed in the U.S. That's a lot of them. They say there's 38 million of them. I didn't test all of them. The sample were the number of the ones that we actually tested. We tested 30 of them. So those are the 30 carbon monoxide detectors. Oh, I did it again. I don't know why I keep trying to put a C in there. Detectors that we tested. They aren't asking us at this point what the response was or what happened with them. There's big group, carbon monoxide detectors in the U.S., sample the 30 that we examined. With that, let's go ahead and talk about a few more definitions. Variables versus data. So a variable is a value or a characteristic that changes among members of a population. A variable is usually what we want to study, right? Your height, miles per gallon for your vehicle, your GPA, your salary. It's some variable, some value, or some characteristic that changes from you to the next person. Data then is the actual response we get back. So variable is kind of like the category, right? If maybe I'm looking at the heights. The data is the actual count or measurements. I'm 5'4". Everything is heights, but variable is our category. The data is our actual physical height, 5'4". Parameters versus statistics. So both of these are a type of data. Or it's based on a type of data. A parameter is a numerical description, like an average, right? It's a specific value that is given to the population. It's a value given to the population. Right? The average age of, that should say, SPC employees. Right? The average salary of an SPC employee. When we're talking about a statistic, that is still a value, but now it's given or based on the sample. So both of these are giving you a numerical value, but one of them is based on the population, which is a fixed value. It will not change. Versus a statistic is based on the sample. And because it's based off of this sample, it can change, hopefully slightly, from one sample to the next. All right, so a parameter is fixed. It should not change because it's from the entire population, where a statistic can change from one sample to the next. Let's put this in an example. So again, still got to remember, let's first identify the population and the sample. Is the highlighted value then a parameter or a statistic? Well, let's find out. After an airplane security scare on Christmas Day 2009, the Gallup organization interviewed 542 American air travelers about increased security measures at airports. The report stated that 78% of American air travelers are in favor of the United States airports using full body scan imaging on airline passengers. So who is our population? Well, the population is American air travelers, right? That's who we focused in on. But did I talk, or did the Gallup group talk to every single air traveler? No. They sampled 542 of them. So our sample here is 542 American air travelers. So the question at hand is, when the report stated that 78% are in favor of the body scanning, full body scan imaging systems, did the Gallup group go talk to every single traveler? Or are they saying that based on the 542 that they talked to? Well, if you said that it was based on the sample, you're right. We know that because they specifically tell us that the Gallup organization interviewed that sample of travelers. So the 78% is what we would call a statistic because it's based on the sample that the Gallup group spoke with. Let's try one more of those. The freshman class at a university has this average SAT math score of 514. So, who's our population? Well, we are referencing the freshman class at a university. Did they say anything about a sample? Did they say anywhere that they sampled 500 of them? No. So that means when they told us that the SAT math score was 514, that would make it a parameter based on the entire freshman class. Because it's at a university, it would actually be very easy for them to run some calculations for every single freshman class member. That's why we're able to say it's based on the population. Population goes with parameter. Statistic goes with a sample. Okay, I have two more quick definitions for us on this video, and then we're going to take a little break and come back. So our last two definitions for this video is to talk about the fact that when we're talking about statistics, right, the big science, right, the big overall statistics, there are two different ways we can use it. We can use statistics to describe something. This is just where I am collecting data. I'm describing my results. I'm displaying those heights or those GPAs. This is when I'm describing something that already exists. However, I can then turn around and use that to make an inferential guess. When I use those descriptive statistics to draw a conclusion, right, to apply that data and draw a conclusion about something else, that is when I am using inferential statistics. This is best going to be seen in an example. This will be our last example for this video. Example 4 says, identify the descriptive and inferential statistics used. AOL had 900 journalists, 50 of them at its local patch news operation. By the end of 2011, Bloomberg expects to have 150 journalists and analysts for its new Washington operation. So I have to first identify the descriptive statistics. The descriptive statistics is where they are describing what they already have. AOL has 900 journalists, 500 of them at the local news operation. There, they are just reporting data. However, let me shift gears. In terms of that inferential statistics, this is where I'm now trying to use what I already have to make an estimate or a conclusion about what's to come. In this case, our inferential statistics is when Bloomberg describes what they expect. They don't have it already, but this is when they're concluding that in the future, by 2011, they wanted to have 150. Now I realize this is a little out of date, but hopefully we can see the difference. Descriptive describes what we already have, describes the data. Inferential is drawing some other conclusion. So with that, let's go ahead and pause this video. We are going to come back with a second video where we shift gears, focusing on actual data, not just definition, but classifying data and sampling for future statistics.